Next, we'll look at the operation of a Johnson counter. A Johnson counter in circuit is very similar to ring counter. The only difference being that instead of shorting serial input to the 10th pin of 7495, we're going to short using a NOT gate. That is, from QD it will go to input of a NOT gate. Output of the NOT gate goes to serial input. So what this does is whatever the output of QD, negation of that will become input to serial input. Right? Now what this gives us is in a ring counter we had only 4 unique states. Johnson counter helps us double that by giving 2n, that is 8 unique states. So at any given point of time you can see there are only 2 bits that are going, any given state can be recognized by connecting a relevant gate to the outputs QA, QB, QC, QD. Right? How do we realize this in using SUN 495? We'll see it in the experiment here. So what we have used SUN 495 IC is here, NOT gate is given here. So the output of 10th pin, that is QD, is connected to input of first pin of the NOT gate. A second pin from the NOT gate goes to serial input. There is no need for parallel inputs here. They have been connected only for the purpose that in case when you switch on the kit, if all the 4 bits are not at 0, we can make them 0. But more often than not, when you switch on an IC for the first time, you will get all the 4 outputs to be at 0. That's the first state for a Johnson counter. Now from here onwards we just have to keep giving the pulses and see the output. So the first pulse makes 1 bit as 1, second pulse makes 2 bits as 1, third pulse 3 bits as 1, fourth pulse all 4 bits are high. Then it will start becoming low. First bit is low, second bit is low, third bit is low, all 4 bits are low. It's the initial state we are back at. So this covers the all 8 unique states for a Johnson counter. That is twice the number of unique states in a ring counter.